Ladies and gentlemen, our class recording for today has started. Let me move this out of the way. And we'll start today with this term. Come on. There we go. Oh. We'll start today with this. So on Friday of last week, we talked about the idea. We talked about Mendeleev and periodic law. So, give me the story, a brief outline or a brief summary of the story of Mendeleev. So, what did Mendeleev do for us? Okay. Rito, go ahead. Made the first periodic table. How did he set up his periodic table, Rito? Okay, set up with increasing atomic mass. So, that is different than our periodic table today, right? Our periodic table today is set up how? Well, yes, but what does it go in order of? It goes in order of increasing atomic number. How come Mendeleev didn't set it up as increasing atomic number? He didn't know about this whole idea of subatomic particles. He had no idea what protons were. He only knew that atoms were different weights or masses compared to each other. Right? So he takes what he knows and he ends up lining them up in order of increasing atomic mass. Angela, go ahead. Because, so he didn't know about atomic number. He didn't know about protons, right? He didn't have the option to line it up in terms of protons because he didn't know about protons, okay? Rito, go ahead. Okay, back in the 1930s, a guy named Henry Moseley develops an experiment where taking the gold foil experiment that Rutherford did takes it another step. Rutherford only found out that the nucleus of an atom has a positive charge. But Moseley devised an experiment and realizes that the nucleus of every atom is actually a different amount of positive charge. And then, a little bit further, realizes that that difference in positive charge is a difference by a factor of integer values. So it's like 1, then plus 2, then plus 3, then plus 4. And that's how we realize, oh, there must be different things in this nucleus that are contributing to that positive charge. That's where we get this idea of protons from. Yeah. All right, good there. Okay. Up on the board is a picture of a sample cell from a periodic table. Some of these I think we're probably pretty familiar with, right? For example, letter A, okay, tells us about the atomic number. Atomic number is important because it tells us the number of protons. Okay? Consequently, it does tell us electrons, although we'll find out as we move along that that's not always the case when we get into a little bit of bonding. Okay? So letter A is our atomic number. Okay? Letter B tells us what about it? That's our chemical symbol or our elemental symbol. I believe we talked about this as we went along, but when we have a two-letter symbol, second letter, lowercase, okay, there is a difference between two capital letter elements and a two-letter symbol that is a capital and a small, right? So you have to make sure that we are writing that properly, okay? Make sure the second letter of a two-letter symbol is always lowercase. Third, letter C is name of the element, okay? And then letter D is the average atomic mass, which we said is a little bit different than atomic mass, right? Atomic mass is the weight of an individual isotope in relation to carbon-12. Average atomic mass takes into account all of that. Okay? Every periodic table is going to give you at least 3 of these things. Every periodic table is going to have atomic number, it's going to have the symbol, and it's going to have the average atomic mass. A lot of them will have elemental names, but not all of them. And then some periodic tables will have more detail than others, so there may be more things on there, just depending on how detailed the person making the periodic table wants to get. But this is the basic information that we need to know to sort of distinguish one atom from other atoms. Okay? Good there. All right. Now let's talk about the periodic table as a whole. First, rows and columns. Are we okay with the difference between a row and a column?
Yeah.
Okay. Rows go which way? Side to side. Okay. Horizontally. Rows horizontally. Columns vertically, up and down. Okay. So keep that in mind. So if you don't have the difference between those two, you're going to get confused. Okay. First, rows on the periodic table are called periods. Each period is numbered, integer values. And those numbers, we will see here in a little bit, are equal to the principal quantum number. Ooh, there's a blast from the past. Each column on the periodic table is called a group or a family. There is no preference one way or the other. So you can call them groups or we can call them families. Doesn't really matter. How they are labeled depends on the kind of periodic table that you have. Currently, most periodic tables, sort of like the preferred method of periodic tables right now, is to just label them from 1 to 18 as we go from left to right. So the column on the far left is labeled column number 1, next one's column number 2, and so on and so forth, all the way across until we get to 18 on the far right. Be aware that other kinds of periodic table numbering systems used to exist. And if you see an old copy of a book or an old copy of a periodic table, you may see some combination of Roman numerals and letters to label the different columns. Like I said, it's kind of an old-fashioned way of doing it, but it does still exist every once in a while, so just be aware that it's out there. No, in this class we'll just go column 1 through 18. So. All right, it's good there. For the next parts, I need you to reach back for me, either literally or figuratively in your mind. And you need to get the orbital filling charts that we used back when we were talking about orbital diagrams and electron configurations. Yes. Okay. No. The filling charts that we used to make the diagram. Literally reach back into your folder if you have it and pull it out. Or if you have it in your mind, you can figure it out.
This finger.
That finger right there. Yeah. Nope. That one. That metal has.
This guy?
Got that one. Yes, right there. From personal experience, you know this. All right. Back on Friday, we began our discussion of periodic law. Okay. To carry on that discussion and hopefully maybe make a little bit more sense out of it, I want you to do the following. Either in the margins of your paper, if you write small, or maybe on a separate sheet of paper, if you don't write small, I want you to write down for me some electron configurations. I would like you to write for me the electron configurations of these 6 elements. Either in the margins on your paper or on a separate sheet of paper. Okay. Please write them down as opposed to just looking at them in your head, because I want us to look at some patterns. So, let's take a couple minutes, write these electron configurations. I'm going to pause the recording and we'll pick it back up when we start talking again. Alright. Alright, we are back live. So, first, the 3 elements that I asked you to write the first electron configurations for, the ones shown up on the board, what do they have in common? Let's start with that. Okay, Audrey, go ahead.
They all end in a sphere with a one thing, whatever it's called, exponent.
So they end in which kind of orbital? A sphere or an s orbital, right?
Yeah.
And how many electrons do they have in that s orbital? 1. Okay. What else do they have in common? Not necessarily this, but Rita, what else? They are in the same family. Yes, they are in the same column, but we gave that a name, right? Okay, so these 3 elements are in the same family or the same group, and they all have an electron configuration where the last electron shows up in an s orbital. The next 3 that I had you do, fluorine, chlorine, bromine. All right, so these 3 elements, again, same family, right? If we look at their electron configurations, again, what do we see? 2s or s2, p5, right? Another thing, they are all in the same family, yes. Okay, so similar. Okay. So similar to the first page. All right. Now, one other thing. Okay. One other thing that we can kind of show about the pattern that's developing here. Okay. Anything else that you notice about this pattern? Oh. Okay, that's kind of just using noble gas configuration. There's one other thing maybe that we can pick up about this pattern that's developing here. So go ahead. Getting there. Madeline, what else? Okay, they're 1 electron short. That's going to be important when we get to bonding. Okay. There's one other thing.
Their endings of the name.
No.
I was going to say
Let's go this. All right. So, what period is fluorine in? 2. What period is chlorine in? 3. What period is bromine in? Right?
What?
Okay.
Why would you do that to me?
Oh,
Okay.
I get it now.
If we go back here, right? What period is lithium in? What period? 2. What period is sodium in? 3. What period is potassium in? 4. So while all of their electron configurations are similar, the row that they are in corresponds or relates to the principal energy level where that electron configuration ends up. So, what we find out is periodic law is the repeatable pattern of properties as a result of similar electron arrangements in all elements of the same family. Their electron arrangements are not the same because they keep getting bigger and bigger and bigger. Remember, an electron configuration is a representation of how electrons are distributed around the nucleus. They are not the same for every element in the periodic table, but they are similar. They differ only by the principal energy level that those electrons occur in. Okay? This similarity leads to this repeatable pattern that we call periodic law. Okay? Sorry, that's the back of this outline. I probably skipped the whole first page. So. Oh, too far, too far. Okay. Elements, sorry, this is the front of your outline, sorry. So, elements in the same group have similar chemical properties. Chemical properties repeat in a predictable pattern where the elements are arranged by, or when the elements are arranged by atomic number. And then, what we find out is looking at the electron arrangements represented by the electron configurations, there is a repeatable pattern of properties because there are similar electron arrangements in all elements of the same family. So similar electron arrangements. Really good.
So, lithium, sodium, potassium aren't in the same family as chlorine and bromine?
Correct.
Even though they have the same number?
No. Lithium, sodium, and potassium are in the same family as each other,
Yeah.
right? And they all have, right, they all have this same ending. Oh, I'm just saying. It's the. Is that it? Libby's the good person. Good. All right, good. Again, fluorine, chlorine, and bromine are in the same family as each other, and they have similar electron configurations. Okay, differing by what row they're in on the periodic table. And we'll find that of any family on the periodic table. That's true. All right, let's finish this up. So, on the periodic table, when we look at these patterns of electron arrangements and how it affects properties, we find out that there are 4 main sections of the periodic table. Now, starting tomorrow and into Thursday, we will continue to talk about some more subsections of these big 4. But these big 4 are a good way to start off. Remember our activity back on Friday where I had you classify all those foods that were in my kitchen, right? We said that certain groups are better classifications than other groups. When we classify things, right, we're starting to look for sections where elements within that section have similar properties, right? The closer they are to each other, the better classification system it is, because then we can make predictions about what other things in that group are like based on what we know about the things already in that group. Okay? Good there?
Yeah.
Okay. If you have a copy of the periodic table from the planner, if you have your planner periodic table, that might be a little more helpful for this section than the green periodic table. Just saying, if you don't, it's okay. All right. But, so let's take a look at where these things show up on the periodic table. First, I'm going to start you with your transition metals. Okay? So, transition metals, these don't necessarily have to match the color of mine up on the screen, as long as you know which color you're coloring which part of your periodic table. You don't necessarily have to color all of them in, just like I colored here. You can outline or crisscross or whatever. Okay. So, your transition metals show up in the 10 columns in the quote-unquote short part of the periodic table. Okay? In addition to those 10 columns, the 2 rows, each of which has 14 columns underneath the main part of the periodic table, also count as transition metals. Although those 2 rows on the bottom we give a special name, we call them the inner transition metals. The top row is sometimes called the lanthanides or the lanthanide series because the first row starts with the element lanthanum. The second row on the on that bottom part, sometimes called the actinides or the actinide series, because the first element in that row is actinium. But all of the elements that are shaded here are metals, or sorry, transition metals. Yeah, there's actinoids, actinides, actinide series. Those are all just sort of different ways of stating the same thing. So if we talk about the transition metals, we're talking about that short section on the periodic table, right? 10 columns representing 10 different families. All right, good there? Okay, now, not to confuse you, but the transition metals are a more specific grouping of a bigger group that we call metals. So, all of the ones we just colored are metals, but there are also some in addition to the ones that we just colored that are classified just strictly as metals. So you need to know that transition metals are metals, all transition metals are metals, but not all metals are transition metals. Yeah, exactly, right? Where a rectangle would be the more general term for a metal, but then specifically transition metals would be a specific kind of rectangle. Now, if you notice in your planar periodic table, there are a couple of squares down in the bottom right that they have classified as metals that I haven't. Go by what your planner says. Okay? So there's a couple of squares down here in the bottom right that I haven't colored in here, but your planner has as a metal. So make sure you follow by what it says. Okay? All of the ones, actually all these yellow ones down here. Okay? So on your planner periodic table, the first 2 columns on the far left, group 1 and group 2 are metals. Stop. So 13 through 16, part of them are metals, but not all of them. The elements that are in yellow are metals.
Wait, what about the green one?
Gray.
Green or gray?
Gray.
The green ones are not.
What's the green one?
That's sort of a dividing line. We'll talk
What
about
about
that.
the gray ones? What about the gray ones?
Yellow.
I'm not.
Those are not- we'll talk about that. column that is blue, the column that is pink, and the columns that have partial purple are all non-metals. Okay?
Wait, so pink.
So blue on the far right, pink the next one over, group 18, most of group 17, and all of group 17, and then parts of groups 14, 15, and 16 are all non-metallic. Non-metals, the only thing non-metals really have in common is that they are not metal. There is a lot of variation among our non-metallic elements. Some of them are solids, some of them are liquids, some of them are gases. Some of them are very reactive with other elements, but some don't react with anything else. So the only thing that they really have in common is that they are not metallic. Okay? Again, follow your periodic table in your planner.
Everything other than transition, not like anything other than metals. So all of this. Wait, what about all of this?
What's wrong?
So this one's colored too.
What's it? Is it this red line? No.
No, that's sort of the dividing line. Right now you have recorded
Wait.
touching the red line. Okay, you shouldn't have.
Well, except for aluminum. So this one.
As usual, when we record you guys, we don't get all the way through what we're supposed to do. So. All right, we'll finish this up tomorrow, and then we will start looking at specific families. If you borrowed colored pencils, please bring them back up here.